How are you doing?
I'm good, sir. How are you?
Very good, very good. So last time we learned something about the compound angle formulas in trigonometry. Did you
Right. Yeah.
understand them all?
Yes, I did, and I did a couple questions from my book as well.
Mhm.
They made a lot of sense, and especially you going through the four main ones and then finding deriving the other ones that were on that page that you had was really helpful because, like, whenever I'm stuck, I know I just need to go back to the foundation and then just go from there. It's nothing to get like scared about. So yeah.
Oh, perfect. Now, I've picked up a very interesting question, which is from one of your previous test papers. Let's go through that question. It will kind of review all the concepts which we have learned so far. So
All
let
right.
me just share the screen with you. I'd like you to make an attempt to solve this. So can you please read the question here?
Yes. So given that t equals tan x over 2 for theta, which is in between minus 360 and 360, show that cos x equals 1 minus t squared over 1 plus t squared, and sine x equals 2t over 1 plus t squared.
Correct. How will you solve this question?
So you have to use, obviously, one of the formulas.
Right. So here's the formula list. That's the formula list, correct?
All
So
right.
we are given half angle in this particular case, right?
Yeah.
And we need to use the double angle formula with cos tx. We have three of them right there, correct?
Mm-hmm.
So any one of these can be used to get you the answer. So that is what you need, correct?
Right.
Okay. So now we have a look at the formula. Let's look into the question once again. So the question says that we are given that t is tan x by 2. You have to
Mm-hmm.
find what is cos x. So first, we could find what cos x by 2 is, right? Because we know tan x by 2, correct? So
Yeah.
first step is to find what is cos x by 2.
X over 2. Yeah.
So once we do that, then we can find what cos x is because that is twice this, right? So cos
Yeah.
x will be what? Cos x will be equal to cos of twice this angle, x by 2,
X over
right?
2. Yeah.
So you could use any of your formulas. Since you know cos x by 2, the best formula will be 2 cos square x by 2 minus 1, correct?
Yeah.
So then you'll get your result. Is that clear to you?
Right. Yes.
Now, since you know what is tan x, t is tan x by 2, that really means if I have a right angle triangle as shown here, and the angle is x by 2, tan is what? Tan is ratio of opposite over
Adjacent.
adjacent, right? So
Yeah.
that ratio. So that means tan is t, that means t and 1. Those are the sides, right? Opposite and adjacent.
Mm-hmm.
Okay. So t is equals to tan x by 2. With that, you can make this right angle triangle where the angle is x by 2. Side opposite will be t and adjacent will be 1, right?
Right.
Now you can use the Pythagorean theorem to find the hypotenuse, which is t square plus 1 square square root as shown here, right? So from here, what is cos x by 2? Well, cos x by 2 is adjacent over hypotenuse. That means it
Hypotenuse.
is 1 over square root of t square
T squared plus 1.
plus 1. Clear? So easy.
Yeah.
So if you go systematically, the question may look very difficult, but it is not that difficult, right? Yeah. Now we apply this formula that cos x is basically equals to 2 times x by 2, 2 cos square x by 2. So let's do square of this, right? So 2 times square of this thing, which is 1 over square root of t square plus 1 whole square, right? Minus 1, correct?
Mm-hmm.
So do you see how easy it is? We found cos of x by 2 and then substituted the value to find the cos x, right?
Mm-hmm.
So square of this, the radical portion will go, right? So you get
Right.
what? 2 over t square plus 1, right?
Yeah.
Minus 1. Now you can
1.
take a common denominator. T square plus 1 is the common denominator. And you get 2 times, you can rearrange, right?
Yeah.
So 2 minus t square minus 1, because that multiplies, right? T square plus 1. And what do you get? The expected answer, which is, because 2 minus 1 is 1, right? So we get 1 minus t square over 1 plus t square. Correct?
Oh.
Is that
Mm-hmm.
clear?
Yes. Yeah.
So that simplifies to what is required, 1 minus t squared over, you could write 1 plus t squared.
Right.
So we got the first part, which is we need to show that cos x is 1 minus t squared over 1 plus t squared. Now, second part, sin x is 2t over 1 plus t squared. How will you solve this now?
So what's the formula for sin x? Or is there a formula? Can we? Oh no, we just need to do opposite over hypotenuse. Yeah. Got it.
Excellent. So just need to do as you said. We'll again make a right angle triangle similar to that, correct? Let's say this is a right angle triangle. Now we know that cos of x is basically equal to 1 minus t square, which is the adjacent side, right?
Yeah.
Over the hypotenuse, which is 1 plus t square, right?
Yeah, and then use those values.
Use those values to find this value.
Right.
You'll get that value as 2t, correct?
Yeah.
And so sin x is 2t over 1 plus t square.
Makes sense.
Is that clear to you?
Yes, very clear.
Don't reapply the formula to calculate unnecessarily.
Yeah, I was just about to do that, and then I realized what you just did. So yeah.
Use this triangle and get your solution. Is that part clear to you?
Yeah, very
It
clear.
is actually a very tough question. It looks very simple here on this page, but otherwise, it is a very tough question from examination point of view.
They don't give the triangle, do they? You have to do it yourself.
They don't give the triangle. They give you the question, yes.
Yeah.
Now, the second question is related to the first question, as you see in most of your examinations, correct? Your part A, B, C, D, and all, correct?
Right.
Now, second question is related to the first. It says, use t equals to tan theta by 2. So whatever t we are looking at, to solve for 3 cos theta plus 2 sin theta equals to 3, when theta is between minus 360 degrees and 360 degrees. So that becomes an equation based on our question. Is that clear to you?
Right. Yes.
So now, how will you do this? Tell me.
I was thinking of something crazy, but I think it's a bit stupid now. I was going to square the whole equation because the trigonometric identities where you have, like I can sub, so let's say it becomes sine squared theta, I can just sub that as 1 minus cos squared theta and just work with cos. And then to go back to tan is basically sine over cos, but then I'm bringing sine in again, so.
Yeah, no point. So what you do is, see, in the part 1, we know if t is tan x by 2 or t is tan theta by 2, what is cos x? Cos x is 1 minus t square over 1 plus t square. So I'm going to substitute, right?
Yeah.
So I'm going to substitute this value with here and that value for sine. Is that
that makes more sense.
We get one equation in t.
Right. That's
So and that is equal to 3. So we have an equation in t. So we will solve for t, correct?
Yeah.
Once you solve for t, then we know t is tan theta by 2. Then we'll solve for theta by 2 within even domain. You get the idea?
Yes, yeah.
So it's a very tricky question, excellent question. Now let's look into the solution and then we'll go slowly. So first part, slightly simpler. Can you please read the solution?
Yes. So given that t equals tan x over 2 for x in between minus 360 and 360, show that cos x equals 1 minus t squared over 1 plus t squared and sin x, which equals to 2t over 1 plus t squared. So sketch the triangle for t equals tan x over 2.
Correct.
Then cos x equaling 1 over root t squared plus 1 and sin x over 2 equaling t over root t squared plus 1.
Correct. Simple as that. Now part B, we'll apply the formula, correct?
Yeah.
Now I mean the same part because we need actually cos x, right? We need actually cos x. So that is x by 2. So we apply the double angle formula. Yes, continue.
Yeah. So so like you said, sir, we use the formula. So cos 2x equals 2 cos squared x minus 1. So that means cos x would just be half that. So 2 cos squared x over 2 minus 1. And then what you did you subbed in. Yes. Nice. So cos x, and then subbed in that. So 1 over root t squared plus 1 squared minus 1.
Yes.
And then you simplified. Yeah. And then we showed that it equals to cos x.
Correct.
Yeah.
Then you make a new triangle and show that sine x is 2t over that. Is that clear to you?
Right.
So we have
Yes.
made a new triangle where the angle now is x, and we already know what is cos x. Cos x is 1 minus t squared divided by 1 plus t squared, which is the hypotenuse, correct?
Right.
Using the Pythagorean theorem, we can find the opposite side, which comes out to be 2t. And therefore, sine x is 2t over 1 plus t squared. Clear?
Right. Nice.
Perfect.
Yeah.
Now let's look into the second part, which is very tricky. Now we are given that t is tan theta by 2, and theta is between minus 360 and plus 360. At this stage, what is theta by 2? We have to figure this out, right? So theta by 2 will be half, which is between 180 degrees and minus 180.
Minus 180.
Yeah, I should have said minus 180 first, or within this interval, right? So minus 180 to plus 180. Now, we need to show, we have already done this part. Part A is 1 is over. T is tan theta by 2. Solve for 3 cos theta plus 2 sin theta equals to 3. Since we know that cos theta is basically equals to this 1 minus t square or 1 plus t square, I'm going to substitute that in the equation, correct?
Yeah.
So in the equation 3 cos theta, I got 3 times 1 minus t square or 1 plus t square. Instead of sin theta, I'm going to substitute 2t over 1 plus t square, and that is supposed to be equal to 3. So we get our equation in t.
Right.
We can multiply all the terms by the denominator, 1 plus t square. So we get the next equation, 3 times 1 minus t square plus 4t equals to 3 times 1 minus 1 plus t square. Now just get all the terms to one side and simplify. Simple as that. So you get it in factored form, which is 2t times 3t minus 2. That gives you two solutions. One is t equals to 0. The other one is t equals to 2 over 3, correct?
Yeah. Yeah.
Now, t is basically equals to tan theta by 2. So equate tan theta by 2 as 0 and tan theta by 2 as 2 over 3, correct? Solve for both of them. Now, within this domain, which you're looking at, is 180 minus 182 plus 180. Within this domain, we have to find this. Get the idea, right?
Yeah.
Within this domain, we have to find when is theta equals to 0.
Right. Okay.
You know, it has got these curves at minus. So we'll see this is 0, like, you know, the tangent graph, right?
Yeah. Yeah. The asymptotes. Yeah.
That is the kind of tangent graph. So from here, when is it equal to 0? Well, it is equal to 0 at minus 180 and plus 180. So theta by 2 is that. So theta is equals to minus 360, 0 and 180. So 0, and then, you know, the next graph will be kind of like this, correct?
Yeah.
Right. So we get these three values, which is minus 180, 0 and 180. The period for tan is 180, correct?
Yeah.
Multiply this by 2 to get the value of theta. So we get 3 answers for the value of tan theta by 2 equals to 0, correct?
Yeah, so the values that you get, you have to make, I think the mistake I made last time was I don't know what I did, but it really complicated. So the values that you get that has to equal 0 has to equal, theta over 2.
Yeah.
Not theta. Yeah, okay.
So normally what I do is I introduce here one step and I say tan alpha, right? So I say tan alpha equals to 0, right? So alpha is equals to minus 180, 0 and 180. And alpha was substituted for theta by 2. Then we write theta by 2 equals to minus 180, 0 and 180, right?
Right.
Degrees, correct? And then you do this step.
Times 2.
Like that.
Oh, I see. Yeah. Okay.
So whatever that angle is, it could be any angle, correct? Right. The angle as such.
Makes sense. Yeah.
So similarly, for 2 over 3, you will need your calculator. Do tan inverse of 2 over 3, you get 33.7. And since you know that the period is 180, right? So take away 180 from it. So write tan, for here, write tan beta.
Yeah, so 33.7.
Right? So beta will be equal to 33.7. And since we know that time period is 180, we are going towards the minus side, correct?
Yeah.
So we will do minus 180. And so you get what? You get the other answer, which is 146.3. Is it okay? So you get both these values.
But you know, using like the cast rule, if you have 33 there, and
The
you
other
want
angle, other angle will be 180 plus, right? Or minus.
plus.
Plus or minus. You could do E because the period is 180. You'll get the same answer.
Okay, but when I added, I got 213, but because
No,
that's not in the domain.
Yeah,
Yeah,
that's not in the domain.
got it.
So
Okay.
we have to go in the left side. So we have
Right,
to
right.
take away. Right?
So yeah, minus 146.3.
And so you get two different values for theta, and that is how you're going to solve this particular question. Is that clear?
Oh, yeah. So this was my other question. So you see how this was my question. It just clicked to me. So you see where theta is. You know,
Yeah.
you can see. I don't know. So you get, let's say you get two values now, so if the two values above where it's theta over 2, if those two values are within the domain, it means theta would also be in the domain.
Yes. So
they're interlinked.
So,
okay.
Therefore, what we did was initially our domain was between minus 362 plus 360.
Right.
That is for theta. So we redefined the domain for theta by 2. And if we take up angles within this particular domain of theta by 2, answer will be within our required domain.
Yeah. Okay. So that's so important by defining the domain. Otherwise, you get everything wrong. That's where I
So initially, when we read the question, we found that the argument was theta by 2.
Right.
The given domain was for theta. We have to rewrite this for theta by 2.
Yeah.
And then take all the values which follow within this particular domain. Ultimately, you'll get the right answer.
Okay. So when I get values for theta, it should follow the domain of the 360 one.
Yes, you should check it. Because sometimes you may overlook, right? So at the end, please check. All the answers which you have mentioned should be within the domain they are asking for.
Yeah, because I think I got caught up at one time and put the theta values. It was in the domain of my changed one, because that's what I was looking at. It was the wrong domain. So I need to make sure, I get that right. Okay.
You understand? So this question actually summarizes all what we have learned so far. It has got all these components in it.
All right. Okay.
Compound angle formula, we have totally, applied it for half angle, for double angle, correct? And then solving trigonometric equation where the domain is different from the normal domain, correct?
Right.
And we are getting multiple solutions. See, we got how many? 5 solutions for this particular equation.
Correct? Right. Yeah.
So I think that's kind of very important. Try to do some more similar kinds from your previous test papers. If there is any difficulty, do let me know, okay?
Okay, will do.
So we'll end the class here. I'd like you to summarize today's learnings.
All right. So we kind of started off the lesson with that right angle question. And again, when I saw it first, I was kind of going into all those compound angle formulas that you taught me. Although they are like important to know, in that kind of situation, there was an easier way to get around it, which was just using your basic trig. And like you said, so it looks complicated, but if you just literally do your SOHCAHTOA, it makes so much sense. And creating that right angle and visualizing it like that helps you obviously do the follow-up questions, as is always part A, B, C, and D. Okay. And then when dealing with the using the formulas and subbing in different things and working out trigonometric identities, again, all really helpful and relevant. And even the last part with just the domain thing, I struggled with it so much, and I just thought that I'll just get around it by memorizing, but it just clicked for me when you talked about it. So now I think that's instilled in my brain. So thank you. Honestly, it's a lifesaver. Yeah. So yeah.
Okay, so we'll continue with this trigonometry. We'll do the simple harmonic equation, which is extremely important in the next class.
Okay. Perfect.
In between, if there are any difficulties, feel free to contact. Okay.
Thank you so much, sir. I really appreciate it.
Thank you and all the best.
And thank you, sir.
Bye.
Bye.